Hi, I'm Dion from mathsvideos.com. Now the first part of this question is reasonably straightforward. All you have to do is know that you're working with two different radii. So we just draw in our two radii first. We call the big one R1 and we call the small one R2. So we know that the area of this shaded region here and all around, all this shaded region here is the area of the big circle minus the area of the small circle. So that's pi R1 squared minus pi R2 squared. So we just work that out. Pi R1 squared, we'll just leave it as it is. Minus. Now we want to get it all in terms of pi R1 squared. So this R2, we need to change this. So we know from Pythagoras theorem that x squared plus R2 squared is equal to R1 squared. So that implies that R2 squared is equal to R1 squared minus x squared. That implies that R2 is equal to the square root of R1 squared minus x squared. So we just replace that here. So that's minus pi times R2 squared. So we just square this term here. So that's just R1 squared minus x squared. So we multiply that out. That gives us pi R1 squared minus pi R1 squared, convenient enough, plus pi x squared, pi x squared. So these cancel out. So that just gives us pi x squared. So the area of this shaded region here, the whole way around, is pi x squared. So now on to the second part of the question here. We're asked to find the area of this shaded region underneath. Well, shaded now. Let's find the area of that region there. So really what we're asked to do is we're going to find the area of this sector here. And then we're going to take away the area of the two triangles, and that gives the area of BC. So I'll just write that down. Area of sector, that equals to the area of sector. Area of sector minus the area of two triangles, minus the area of two triangles. Okay, so now what we have here, we have 2x here and x here. We just write R1 here. Okay, now we know we call this angle here theta. Okay, now cos theta is equal to x over x squared, or 2x. And x over 2x, which is equal to a half. That implies theta is equal to 60 degrees. Or pi over 3. And we know that if this is equal to 60 degrees, then this is equal to 30 degrees. So just write in 30 degrees there. And then we know we're just drawing this other triangle here, that's equal to 30 degrees here as well. So okay, now the area of sector, the formula for the area of sector is a half pi squared theta. A half pi squared. Now theta in this case is going to be 60 degrees, which is pi over 3. Sorry, a half r squared, pi over 3. Minus the area of the two triangles. Now the area of this two triangles here is just, if you treat it as one big rectangle, because we've got 90 degrees here, we can do that. It's just R1 times x. Now we have to change R1 around because that's not in our answer. So R1, we know that tan theta is equal to R1 over x. Implies x tan theta is equal to R1. R1 is equal to x tan theta. So we just replace this. So we have a half 2x squared, sorry, our radius is 2x, so that's a half of 4x squared times pi over 3. I'll just rewrite this as a half of 4, which is 2. So it's 2x squared pi over 3 minus x tan theta, so it's x squared tan theta. So we know that tan theta is root 3, because tan of 60 degrees is root 3. So that is, we take out x squared as a factor here, so x squared into 2 pi over 3 minus tan theta, which is tan of pi over 3, which is root 3, which is your answer. Okay, so if you found this video useful, please add me on Facebook or Twitter, or subscribe to my YouTube channel where I have loads of Leaving Cert Maths videos. I'm going to cover the last 6 years. Cheers.